The foreign currency exchange market is the biggest financial market in the world. It is a typical complex system and can be presented by the correlation networks and minimum spanning. Many studies show that the method of centrality can be used to describe the characteristics of the forex market. The project will study a set of currencies raised during the COVID-19 period from 30 December 2019 until June 2021. The analysis of the Forex network aims to review the information about the market structure and the role of each particular currency. The expected audience of visualizations will be investors and companies who want to develop the new investment strategy during the pandemic period. The trend of influential currencies tends to impact other related currencies. The analysis also suggests which currencies should be monitored carefully and identifies currency clusters to help investors diversify their portfolios. The daily closing price of 58 currencies are retrieved from the exchange rate service. The attributes involved in the dataset are currency symbols, daily closing prices, and dates. A table is constructed to display the country name and their respective currency symbol. The project used US dollars as the base currency to state the daily exchange rate. The heat map is a conventional method to illustrate the correlations between sectors. Constructing the heat map of the correlation matrix is necessary. It helps to validate the results from the correlation calculations and provides a high-level understanding of relationships between currencies. Although heat map is helpful, it can only present one dimension of data. As the outline purpose of the project, even with a heat map, crucial issues about the most influential currencies and their behavior remain unanswered. The currency network will be utilized to study further based on initial findings achieved from the correlation heat map. The visualization of the currency network also provides a more accessible method to convey meaningful messages. The minimum spanning tree contains the edges that link all the nodes together, minimize the sum of edge weights, and do not include any cycles. The project will implement Kruskals algorithm in building the minimum spanning tree, which would help to understand, simplify, and summarize the message obtained from the currency network. To construct the clustered heat map, the Panda library is used and load data as a data frame. The built-in correlation function is used to compute the pairwise correlation between currency. Python provides a data visualization library called Seaborn, which visualizes the correlation matrix as cluster heat map. Then after the data is loaded into MATLAB, the correlation matrix and distance matrix are calculated. The output network function, which takes the matrix and an array of currencies labels as parameters and returns two CSV files. Those files are loaded into Gephi to generate network visualization. Gephi provides built-in plugins to calculate the measures of centrality and minimum spanning tree. Color Bureau is an online tool that is used to select appropriate color schemes for all three visualizations. Many studies propose methods to analyze the correlation network of the world currency exchange rate. Paper written by Kazemi Larry examined the network topology of the forex market from 2009 to 2012 based on centrality methods. Their paper successfully pointed out nine influential currencies during this period and suggested investors and companies should monitor these currencies carefully. A paper written in 2009 also provided the analysis of a network structure of the foreign currency exchange market. This paper did identify the clusters of strongly connected currencies and study the network topology of minimum spanning trees constructed by different base currencies such as GBP or USD. The analysis indicates that euro has played a crucial role in the global forex market. There is also an interesting reading that discusses visualizing asset price correlation written by Julian West in 2019. In this article, the author showed how to visualize the correlation matrix of asset price as an interactive network graph and provides the audience with a high-level overview of the connection between asset classes. In terms of algorithm and visualization techniques, before constructing the heat map, data is normalized and converted into log returns. The correlation function is used to compute the pairwise Pearson correlation between currencies. The cluster map function visualizes the correlation matrix as a cluster heat map. The Marchenko-Passer distribution is implemented to detect and remove insignificant eigenvalues and eigenvectors of the matrix, reduce noise, and make the matrix display only meaningful messages. Gephi used the Loven method to compute the modularity and detect community structure in networks. The correlation matrix is transformed into a distance matrix. In Gephi, a plugin called Minimum Spanning Tree implements the Costco's algorithm to construct the forex network. Gephi also performs centrality calculation and produce the value of cloned centrality between each centrality, Dewey centrality, and eigenvector centrality for each currency. Looking at the clustered heat map, overall, the strongly negative correlations are hardly seen between currencies. The currencies that are close to each other according to geographic regions tend to be grouped in the same cluster. For example, it is shown in the visualization that the list of currency run from the Switzerland to Poland are mostly European currencies. The Commonwealth countries are grouped into a cluster and there are also a cluster of non-European regions, which consists of the list of currencies run from Indonesia to Africa. Most of those currencies come from the Asian region. The Loven method successfully detects four groups of currencies behave similarly. The four clusters that can be seen from the graph: orange, green, blue, and gray. It is noticeable that European currencies are strongly correlated to each other and have a significant correlation to other currencies. It is also noteworthy that even Turkey and Russia come from Europe. They have no correlation with the European currencies. It might be because of their unique geographic position. Both Turkey and Russia are lying partly in Asia and partly in Europe. It is shown that European currencies are grouped into two different clusters. The minimum spanning tree is a more readable and well-structured version of the previous network graph. There is some knowledge obtained from the minimum spanning tree. The NOK connects currencies from four different regions. The currencies of Europe are the most closely linked. Euro has a predominant position in the European monetary system. About the format and structure, suitable layout algorithm is implemented to separate the clusters and help the audience distinguish them easily. Labels of the nodes do not collapse to each other. In terms of choice of colors, a diverging colorblind-friendly color palette is used to colorize the heat map. A qualitative color palette is used to colorize the cluster in network graphs. The color sets are generated using the Color Builder tool. There are no issues such as simultaneous contrast and apparent size in the use of color. The title and legend are also added to help the audience understand the context and interpret data. In the heat map, lines are used to illustrate the relationship between currency clusters. And in the network graph, lines indicate the orientation between currencies. The visualizations have sensible use of type. The types do not overpower the graph. Minimal type successfully enhances the images. The expanded and minimal background color is used to enhance the distances. The pure white background for each visualization creates a clean, cohesive, and professional look. The number of clusters is ideal so that it does not increase complexity of the graphs. So about the things that work well, some basic findings of this project seem to be consistent with the result achieved from other past studies, and moreover, all three visualizations achieve the purpose aim and deliver a meaningful message. The analysis can be a useful resource for companies and investors to take advantage of the market opportunities. However, some problem can be seen in the project is using different environments and tools might cause inconsistency in visualizations output. The work to be done is developing the interactive version of the currency network and mapping the currency network into a geographical layout can provide some interesting insight. So this project employs Pearson correlation coefficient to build the currencies network and provide some basic findings about properties of currencies. One suggestion for future work is making a comparison between currencies from different periods so that it could reflect the impact of COVID-19 on the forex market more clearly. So thank you for listening.